Hi, and welcome to AWS Julie. We're starting a new playlist that covers the data engineer fundamentals to help you prepare for the AWS Certified Data Engineer Associate exam. Let's start off by defining what is data engineer. There are a lot of definitions that I found out there, but basically a data engineer gets data, stores that data, and prepares it for consumption by data scientists, analysts, and so on. And then this data can be used for analysis, machine learning, and more. Now let's define what is data engineering. Data engineering is the development, implementation, and maintenance of processes and systems that ingest raw data and produce high quality and consistent data. So as a data engineer, you must incorporate security, data management, orchestration, data architecture, software engineering, and operations to manage the lifecycle. The goal is to take raw data and make it easy and reliable to work with and integrate across different data sets and domains. And then you can use methods and tools such as streaming, extract, transform, and load, data warehouses, and data lakes. Data engineers create data pipelines, which are infrastructure designs for data analytics, while meeting requirements to build data pipelines. So in this course, we're going to talk about AWS data engineering tools that help data engineers to build AWS data pipelines, manage data transfer, and ensure efficient data storage. Another fundamental needed for this exam is to understand the data engineering lifecycle. The lifecycle focuses on the data itself and what end goals and requirements are needed from that data. So the stages are generation, storage, ingestion, transformation, and serving. Let's pause here and ask a question. What is the difference between the data engineering lifecycle and the data lifecycle? Well, the data engineering lifecycle is a subset of the whole data lifecycle and focuses on the stage a data engineer controls. And remember that in the entire lifecycle, you must include security, orchestration, data architecture, and more to ensure you understand how to evaluate data tools and how they work together in this lifecycle, but also understand how the data is produced in the systems and how analysts and scientists will consume that data. And in doing all of this, you have to ensure you can manage the pipeline and consistently review and improve to optimize your cost, scalability, agility, reuse, and more. We mentioned a bit ago about software engineering, which is needed to be able to use technologies such as Hadoop, Spark, Teradata, Hive, and more to create a data solution. You need a solid understanding of software engineering, networking, distributed computing, storage, and more. You should be familiar with different languages such as SQL, Python, Java, Bash, JavaScript, C#, and more. And I'm in the middle of an awesome SQL course that I'm really loving. Under this fundamental lesson, I also want to briefly talk about the AWS Data Engineering Toolkit, and we're going to dive deeper into these throughout the course and talk about different AWS services for the different stages of the data engineer lifecycle. Traditionally, big data processing systems were built in data centers. AWS offers multiple different services for data engineers to build complex data analytic pipelines. And it is important to understand and note that there are multiple different AWS services you can use to achieve specific outcomes. So as a data engineer, you must have the needed depth to choose the best services for your requirements. Being able to choose the right tool for the job is just as important as knowing how to use it. Our goal as data engineers is to build robust data sets that answer broad classes of questions, and the goal is to have that data to be the source of truth. Let's get started with the first task from the AWS Certified Data Engineer Associate Exam Guide, which is Domain 1, which is data ingestion and transformation. Let's jump back to our fundamentals and talk about what is data ingestion. So data ingestion is the process of moving data from one place to another. Let's dive a bit deeper and ask if you can tell me the difference between data ingestion and data integration. Well, we just said that data ingestion is moving data from one place to another. And in this diagram on the slide, we are moving data from the on-premises corporate data center into an S3 bucket. Data integration combines data from different sources into a new data set. So what is an example of data integration? My first thought is using data integration to combine data from advertising or web analytics data to create a user profile. And you could then save that user profile in your data warehouse. And we're talking about data integration because it is part of data transformation, which is also covered under this domain. For this exam, ensure you understand different ways to ingest data, such as direct database connections, change data capture, APIs, message queues, event streaming platforms, databases and file exports, object storage such as Amazon S3, to move data in and out of data lakes between teams or between organizations. And also ensure you understand different ways to transform your data. So dive deeper into querying, modeling, and transformations for your data. Let's get started with task statement 1.1, which is to perform data ingestion. And again, this is the first test from Domain 1 for the Data Engineer Associate Exam Guide. And before we begin, let's step back to our fundamentals and talk about the data engineering lifecycle that we were just talking about a few minutes ago. Remember, the steps or stages are generation, storage, ingestion, transformation, and serving data. So let's quickly cover the first two steps before ingestion, which is the focus of this task statement. And we're going to start with generation. Generation is where your data originates from, so it is your source system. This could be an IoT device, a transactional database, an application message queue, and so on. And for this generation stage, the data engineer consumes that data from a source system, but we don't necessarily control that source system. So ensure you understand how the source system works, the way it generates data, the frequency and velocity of data, and the types of data being generated. Here are a few questions to consider at this generation stage. What are the characteristics of the data? How is the data persisted in this source system? Will there be any duplicates? What is the schema of that source data? And does that schema change? And more. The next stage of our data in lifecycle is storage. So ensure you can choose an appropriate data store to store the source data. And we'll cover this stage under Domain 2, which is data store management, but I wanted to mention it here as the second stage of the data lifecycle and remind you to understand different use cases and different AWS storage services to ingest your data from the source system into AWS. Now let's move on to the third stage, which is ingestion and the focus for this task statement. So after you understand your data source, the characteristics of the source system, how that data is stored in the source system, and have a plan or design to store the data ingested, you then need to gather and ingest that data. A few questions to ask yourself here are, what are the use cases for the data being ingested? Where will this data go after it's ingested? What is the frequency or volume of data being ingested? And what format is the data in? And more. There are two major ingestion concepts to consider at this stage: batch compared to streaming and push compared to pull. Dive deeper and ensure you understand each of the differences of batch, streaming, push, and pull for this exam. Also ensure you understand replayability of your data ingestion pipelines. Replayability helps you to reprocess data in case of failures, updates, or changes in the pipeline logic. What are considerations to achieve replayability in your data ingestion pipelines? Well, I always recommend designing your data ingestion pipeline in an event-driven manner. You could use AWS services to collect and initiate events when new data arrives or if a change occurs, such as Amazon S3, Amazon Kinesis, and Amazon Event Bridge. Make sure you test the replayability of your data ingestion pipeline using different failure scenarios and reprocessing scenarios to validate that the pipeline can accurately and consistently reprocess data without data loss, duplication, or integrity issues. Also, ensure that the pipeline components are independent. It can run multiple times without causing unexpected or duplicate results. This helps the pipeline to process the same data multiple times without data duplication or inconsistencies. Also, configure checkpoint mechanisms within the pipeline to track the progress and state of the data processing to determine the last successful processed data point. Then the pipeline can resume processing from that point in case of failures or interruptions. You can also add data versioning with your data ingestion pipeline. Also, store the raw or intermediate data in a durable and scalable storage service such as Amazon S3. This ensures that you retain the data for a period of time for compliance requirements, data governance policies, and for replayability. And then, of course, add logging and monitoring within the data ingestion pipeline to capture relevant logs, errors, and metrics to track your progress, identify failures, and analyze that behavior of your pipeline. And finally, you can use infrastructure as code tools such as AWS CloudFormation or AWS CDK to automate your deployment and configuration of your data ingestion pipelines. And we're going to talk more about infrastructure as code in the last test statement for this domain. For this exam, make sure you're familiar with the common use cases for data analysis. Be sure that you know the AWS services related to each use case. Know the different AWS services, or know how the different AWS services are implemented and the characteristics that indicate which service to select. For example, Amazon S3 is great for data lakes. A big advantage of a data lake is that you don't need a predefined schema. If you need a data warehouse or lakehouse, you can use Amazon Redshift or Amazon Redshift Spectrum. For this, you can run SQL and complex analytic queries against structured and unstructured data without the need for unnecessary data movement. For big data processing, Amazon EMR can quickly and easily process vast amounts of data for data engineering, data science development, and collaboration. And for real-time analytics, Amazon Kinesis can collect, process, and analyze streaming data as it arrives into your data lake and respond in real time. For operational analytics, Amazon OpenSearch Service can search, explore, filter, aggregate, and visualize your data in near real time for application monitoring, log analytics, and clickstream analytics too. So we keep mentioning the object of ingestion is to ensure that you understand how the frequency, volume, generation, and source system of that data can then dictate the solution that you would choose for your data storage. Let's jump back to fundamentals. What are the 5 V's of data? Variety, volume, velocity, veracity or validity, and value. Variety is the type of data. So this could be web server logs, videos, pictures, geolocation data, sensor or IoT data, and more. AWS supports the processing of structured and unstructured and semi-structured data with Amazon services such as Amazon RDS, S3, AWS Glue, and Amazon Comprehend. Volume is the amount of data to be transferred or total size, but also the daily, monthly, or yearly growth of that data. This could be an indicator of the AWS services to use. Some services have limits on item or record sizes, so ensure you're familiar with that information. Other services have limits on the total size and storage volume. Pay attention to throughput as well because it can also include networking services in addition to the traditional data analytics services. What are AWS storage services for large volumes of data? S3, Amazon EBS, Amazon Redshift, and Amazon DynamoDB. Velocity is the speed of ingestion and processing of our new data from the source system into the target storage system. You need a solid understanding of how quickly the source data is generated and how quickly that incoming data must be processed. The frequency of the data is a property of the producer that sends data into your source system. Pay careful attention to the difference in real-time versus near real-time solutions. And we're going to talk about this more later on. Also, pay careful attention to analysis requirements that might exist within questions you may see on the exam, because sometimes your data will be transferred during this ingestion stage. So what are services for velocity? Well, we have Amazon Kinesis and AWS Lambda. Veracity is the quality, completeness, and accuracy of the data being ingested. Your data may come from different sources, and depending on how that data is generated, that data might be incomplete or inconsistent. So maybe your IoT sensor went offline or could be missing a period of data. You must be aware of the veracity of that data ingested so you can ensure to include that when you're processing your data. The data collected could be missing values or contain errors, but there are tools available to help detect and remediate fields that contain invalid data. Value is probably the most important. You must consider the data being ingested to ensure how that data is ingested correctly and how that ingested data will add value to the business currently and in the future. If you ingest terabytes of data, then you clean and process all of that data, but the end data product adds no value, then it's a waste of your time and money. AWS has multiple storage services for different use cases and requirements. Know which services can work with and store structured, semi-structured, and unstructured data. Let's jump back to ingestion. You can use the type of data your environment collects and the temperature of that data to determine what kind of ingestion solution is ideal for your needs. What are AWS services that support the ingestion stage of the data engineer lifecycle? Well, transactional data systems need to quickly store and retrieve small pieces of data. Also, end users need quick and straightforward access to the data. So, storage services would be Amazon DynamoDB, Amazon RDS, and Amazon Database Migration Service to ingest transaction data. With the transactional database, the rows in the table are updated regularly. So, for example, a customer moves or gets a new phone number. And with DMS, you can use the database transaction log files to track any updates. It can also be used to migrate existing data systems to a new database engine, such as migrating an Oracle database to an Amazon Aurora PostgreSQL database. And from an analytic perspective, Amazon DMS can also be used to run continuous replication from common database engines to Amazon S3 data lakes. Streaming data such as clickstream logs should be ingested continuously and in real time or near real time. Streaming data is categorized by reading large amounts of smaller events, for example, 1 kilobyte payload that you are continuously writing to a stream. With streaming data, you might need to bound processing by time, event amounts, or particular segments to limit how much data you are processing to produce results in real time. If you have hot data coming in at a high frequency, you want to process that in real time, then a streaming solution might be the best option. And we can use Amazon Kinesis and the Kinesis family that has multiple services that you can use for streaming data depending on the specific use case and requirements. What AWS service would you choose if you had to ingest data using the FTP and SFTP protocols? You can use the Amazon Transfer family for file transfers directly into S3 using common file transfer protocols. What if you need to ingest storage from on-premises? You can use Amazon Data Sync, and it can ingest data from existing on-premises storage system. Data Sync also uses common protocols such as the network file system and the server message block. What if you need to ingest large amounts of data? Ensure you understand the AWS Snow family and know which Snow service works best for different use cases and requirements. Let's move on and talk about batch data ingestion. With batch data, you are typically dealing with larger event payloads and ingesting those on an hourly, daily, or weekly basis using a cron job. You are bounding data by the data source. For example, ingested data stored in an S3 bucket. Batch data ingestion works for colder data that doesn't need to be processed right away. Amazon EMR provides a way to deploy common Hadoop frameworks, and some of the tools can be used for ingesting data from a database. For example, you can run Apache Spark on Amazon EMR and use a Java database connectivity or JDBC driver to connect to a relational database to load data into a data lake. You can also use AWS Glue to connect many different database engines, and through those connections, transfer data for further processing. For your exam, ensure you understand different AWS services to help support the requirements of your systems. Let's wrap up this lesson and talk about how to manage stateful and stateless data transactions in AWS. Stateful data transactions store information about the current state. We just talked about transactional databases. What are AWS services that support stateful data transactions? Well, we have Amazon Elasticache and Amazon RDS. Stateless data transactions do not store data or sessions and do not rely on the past state. And for stateless data transactions, we have Amazon Lambda, Amazon API Gateway, and Amazon S3. Now, in our next video, we're going to cover more fundamentals, and we're going to talk about the second task statement from the exam guide and domain 1, which is to transform and process data.